Please consider this situation. There is an immutable class that contains an immutable list that will keep many instances of an immutable record type. And on top of all that, I want to use Entity Framework Core to persist that model. Will that be possible? With bare EF Core? No. But I will show you a thin wrapper which I have made around EF Core that will make it possible to track immutable, deeply immutable entities. So please step into my office. I have some code to show to you. This code here is using EF Core. Here is the invoice which I have just instantiated. I'm adding it using my implementation called add immutable async, and then I'm saving the changes. This will work like a charm. To show you that everything worked well, I will query the entity from the database and then print it out. When I run the application, you will see that the two printouts are the same, which means that I have successfully saved an immutable entity into the database. I will show you that library later. That's not the most important part of this video. This is important. The immutable entity class. In the previous video, I have shown you how you can store, retrieve, and update an immutable entity which only consists of scalar properties. In this video, we are raising the bar. I will add a collection, a navigation collection to the immutable entity, and that will cause a lot of complications. So right now the class has several immutable properties, but the crucial property is missing. This is the invoice line record, immutable record. An invoice should hold multiple instances of the invoice line entity. It has its own properties and it is stored in its own database table. First, let me complete the story about this immutable class. It also has a copy constructor, and that copy constructor is used to implement non-destructive mutation. Every property has a mutator method which creates a new instance with one property changed and all other properties copied. We will need that with invoice lines too, so I had to show it to you. Now we come to the lines. We add a collection of lines. Is this right? Well, no, of course not. That wouldn't be immutable. I need an immutable collection, like an immutable list of invoice lines. And now a million-dollar question. What will EF Core do when it sees this property? I could also add validation to the init-only setter, but that doesn't change the substance. And I'm still worried about how EF Core will look at it. The copy constructor must also copy the reference to the list. Another method would accept a new list and validate it too. A calculated property could sum up the line values. I'm doing full-fledged immutable design, can you see? I'm completely ignoring EF Core. I don't care about it. I want to have my immutable class the way I have envisioned it. But the question remains, will EF Core have objections to this? Let's check it out. The initial invoice will have two lines. Adding to the DB set will still work. EF Core would iterate through child entities and insert them all. The fact that my class is immutable makes no difference. EF Core would iterate through the navigation collection anyway and insert all the objects there, so this won't disturb it. Finding is more interesting. Finding is interesting because EF Core now has to populate the immutable list. How will that work? First, let me show you. Both inserting and querying of the invoice with the child entities works fine. But how? This is the definition of the navigation collection. The default EF core collection initializer would instantiate an empty collection and then call its add method in the loop. Well, that would obviously explode. It would end in an exception when it comes to an immutable list, because immutable list throws from its add method when used as an iCollection. But EF Core 10 is smart enough to still populate an immutable list when it notices the init-only setter and the immutable collection. It would create the collection in one go and then set it using the init-only setter. In that way, EF Core 10 would avoid calling the add method on the list, the immutable list, of course. And that is why this works out of the box. I had nothing to do to support this. But that is far from everything. I want to test those mutators too. This is the new line to add to the invoice. I will create the updated invoice by starting from the original invoice loaded from the database. And then use the mutators with new customer name, with the lines where the lines are the original lines immutable list with one line added. Notice that the add method in the immutable list returns the new list with everything reused that can be reused from the previous list and one item added at the end. If you are accustomed to immutable designs, you will understand the consequences of this design. The original object is deeply immutable and the new object is the one that differs. On a sideline, the new object is precisely what DB Context Change Tracker has no idea about. But I have prepared my custom update immutable method and I can pass the updated invoice and it will reconcile all the differences compared to the original instance and everything will work perfectly. The magic is here at this line and that magic makes it possible to save changes and literally all the changes will be detected just as if the entities were mutable, and all appropriate SQL statements will be generated and executed on the database, and it will just work. I will show you how I implemented these magical methods, but before that, let me remind you that this video and all videos on my channel are free, but only thanks to the patrons. If you like what you are learning here, then please consider joining the growing community of patrons on my Patreon page. You can find the link to the Patreon page in the description. Thank you very much. Now I will demonstrate that everything worked well by querying the database one last time and printing out the invoice loaded from the database. But I will also print the original invoice so you can see that it didn't change. So this second printout is from the in-memory object. I want to ensure that it really didn't change. This is the point where we are in danger of destroying the original object or at least mutating it, which is against its contract. It should remain deeply immutable. That's what I have promised. Let me run the application and you will see. Here, the updated invoice has a changed customer name and one line added. But below is the original invoice printed from memory, and it didn't change a bit. My entities are deeply immutable and they are still tracked by EF Core 10. It must be magic, right? As I said, magic is in this call. Everything else works natively. EF Core supports adding, removing, and querying immutable objects natively. There is nothing you need to help it with. But EF Core needs help with updates. The answer is in the small library which I have developed. It is under 300 lines of code long, but it's pure evil in .NET. You can find the link to the repo of this library in the description, so please go there and read the code in detail. I will just show you the short story. All you will see is the abstract repository for immutable entities. Those are the find, add, remove, and update methods I was invoking in the demo. They come from this interface. And the crux of the library is in this extension method, which you will never need to invoke directly. This is how it manages immutable updates. It will locate the original entity which the tracker is tracking and detach it. It will then attach the modified entity and mark it as modified. This mechanism is ages old in EF Core, and now it has found its new purpose and new life to support immutable entities. Nevertheless, the story doesn't end there. We had that immutable list. Attaching the modified entity doesn't iterate, doesn't compare navigation properties, neither navigation collections nor navigation references. You have to do that yourself. By the way, this is not a hack. This is exactly what Change Tracker does. All these calls are from documented features. This is pretty normal EF Core extension. The work I had to do was to iterate through all the navigations and recursively resolve navigation collections and navigation references. With that done, all the differences between the modified and the original entity would be discovered and used when generating SQL code, and yet none of the two objects would ever sustain a change in its properties. They will remain deeply immutable. I will show you the DB context too. All you need to do to make all this work is to expose an abstract immutable entity repository instead of a DB set. You do that by calling the convenient extension method on the original DB set managed by the DB context, and that's all. Remember, you can find the link to the library, to the GitHub repo in the description. I think this library is the missing part in EF Core. I would really love to see something supported natively. Until then, we need to find workarounds. Yet, this small library is closing the gap between the change tracker that works on mutable objects, or at least expects them, and the immutable design.